The most common problem which students encounter with physics is they say that it is difficult to solve problems. Difficult to solve problems. This is the main problem with physics, right? Okay, if you just analyze why is it difficult to solve problems, if you just analyze it logically, from where does a problem come? Suppose you get a problem in your question paper. In EAMCET, you will get 40 questions. Out of 40, 35 to 37 questions will be numerical questions only. Hardly 2 or 3 questions will be conceptual. So you will have a lot of problems. Okay. From where do these problems come? Every problem will be given from some chapter that you have in your syllabus. And from that chapter, problem will be given or it will be based on certain concept. And that concept will have some formula. And if you apply this formula to that problem, you can solve it, right? And a very common mistake which many students do is many students relate problems directly with formula. So they think that if you have got a problem, you need a formula to solve that. So what is the formula to solve this problem? How can you solve this? Which formula? Where are the values? You start identifying values in the question first. This is distance, this is force, this is work done. How are these related? You start doing that. And that is a wrong way, that is a wrong approach to study physics. That is wrong. Then how to approach a problem? How to approach a problem? See, if you understand, if you just understand the basic methodology, the basic content of physics, in total physics that you are going to study in first year and second year, the actual content of physics is, I'll say it is only 25%. Actual content. That means physics in physics is 25%. Then what is the remaining 75%? Basic math and vectors. This forms another 25%. So if you are clear with basic mathematics means like algebra, some trigonometry, some geometry, then calculus. Calculus means you have two parts in that, differentiation and integration. So if you are comfortable with this, and along with this, vectors. Vectors is very, very important to understand physics. So this all together forms the basic mathematics and vectors. This forms the 25% of the subject. Then what is the remaining 50%? Remaining 50% is visualization. This is 25% of the physics. Visualization. What do you mean by visualization? Seeing something which is not in front of your eyes is visualization. Suppose now I can imagine that all of you, all these 60, 65 students, they are sitting in front of me in the class and I'm teaching to you. I can visualize that. Of course, I don't know your faces, but I can see that students are sitting in front of me. Similarly, if you read some concept in physics, if you read some definition in physics, or if you read any problem in physics, you must be able to visualize that. Suppose if I tell you that all matter is made up of atoms, and atoms are made up of fundamental particles, electrons, protons, and neutrons. Protons and neutrons are inside the nucleus, electrons are revolving around the nucleus in circular orbits. Then, whatever I told you, whatever audio that you got now, you must be able to convert that into a visual. Like this is the atom. Inside the atom, there are protons and neutrons, and these electrons are revolving around the nucleus in definite orbits. You must not only image, you must see the video of that. Practically, it's like you should go and stand inside the nucleus, and you should see protons, neutrons around you, and you should see electrons revolving around that nucleus. If you could do this for each and every concept, then physics will become very easy for you. Most of the students, they fail in visualization. They go on reading physics just as any language or any other subject. You cannot understand just by reading. You should see. And I'll say, rather, more than seeing, you should also feel physics. If you start feeling physics, it will be the easiest subject for you. You start feeling physics. Suppose in the question you read like a force of 10 Newton is acting on a body. Then you should become that body and you should feel the 10 Newton force acting on you. Then it will be very easy for you to understand what that body will go, how, in which direction will it move. Okay. Or if I in the question, if you see that a electric field of this much intensity acts on a charged particle, then you must become the charged particle. You should feel how the charged particle will feel. You will feel that force, whether it is attractive or whether it is repulsive. Then things will start becoming easy for you. Visualization, very, very important. Then what, this is 75%. What is the other 25%? The other last 25% of physics is, it is common sense. This forms the last 20%. It makes up 100%. Right. Common sense. Common sense is not quite common these days. Common sense is quite uncommon, right? Many of us lack in common sense. And how does common sense help us in physics? There are many situations where we need just common sense to understand. Like, for example, um, in first year, you have got something called torque, and you write torque as R cross F, product of force and perpendicular distance of the force, right? And this torque is utilized in fixing the handles of the doors. This is a door, this is the hinges. The carpenter will be fixing the handle of the door somewhere here, near the edge of the door. Do you see any carpenter fixing the door handle here or here? No. Always handles will be fixed at the edges of the doors. What is the reason? Reason is so that it can be opened or closed easily. If the distance of the door handle is, let us say, it is some 2 meter from the axis of rotation, then R is maximum. I will get torque maximum. If I fit the door handle here at a distance of 1 meter from the axis, then R is decreasing. So to maintain the same torque, you should increase your force. Applied force should increase. And torque is the rotational effect of a force, or turning effect of a force is torque. To rotate something, you need to apply torque. And torque will be maximum when R is maximum for a given force. That's why door handles are fitted here at the edges so that R is maximum, distance is maximum. And who does this?
Hello.
Carpenter does this, right? Do you think that carpenter knows what is torque? That the formula for torque is this. Yeah, R should be maximum, then force will be minimum. Do you think that carpenter knows all this physics? No, it's just common sense. It's his common sense which tells him that fit the door handle here, but not here. That common sense, if you study it in detail, is torque. Like this, I can say that physics is the common sense in detail. If you study common sense in detail, if you attach some science to common sense, you get physics. So physics is not a difficult subject. That's what I want to tell you. It is not a difficult subject. If you have those students who raised hands just now, and even others also, if you have that preconceived notion that physics is a difficult subject, please eliminate it. Please remove it from your mind. Start with a fresh mind. If you are able to see, common sense visualization. These two things are in your hands. You don't find any coaching centers or schools or colleges where you are taught visualization and common sense. It comes from within you. Okay. Basic math and vectors, you should be having the knowledge of these things from your high school. All the math that we use in mathematics, in physics, it's not of so high level mathematics. It's only basic mathematics. If you are able to perform addition, subtraction, multiplication, and division perfectly, if you are able to do these four operations, then you can do squares, square roots. And if you know a little bit of trigonometry, sine, cos, tan, geometry, Pythagoras theorem, and areas, surface areas, volumes of different shapes. And in calculus, if you know what is differentiation and what is integration, I think all of you are from MPC only. So the students who have completed first year, they know quite well what is differentiation. And as most of you are in second year mathematics, you get this integration. If not, if you have not yet got it, you will get it in the coming chapters, integration. Okay. And out of the differentiation and integration that you study in mathematics, we will be using only 10% of that in physics. Only 10% of what calculus you study in mathematics is utilized in physics, basic formulas only. Okay. So that means basic mathematics and is also known to you to a large extent. Basic mathematics, you already know it, you have already studied it. Then this comes vectors. And again, if I go back to mathematics, you have a chapter on vectors also in maths. And out of that content of vectors that you study in mathematics, we will be using hardly some 30-40%, let us say maximum 50% of vectors in physics. Okay. So you must be comfortable with basic math and vectors also. That means if you are having these three skills, basic math, visualization, and common sense, the remaining thing is what I am trying to teach here. Okay. So if you are comfortable, if you are problematic, or if you find this part of the physics, content of the physics difficult, then I am here to help you. I will make it easy. I guarantee you that I will make the content of physics easy for you. But I require these three things from you. Okay. Or at least these two things. I will handle this also when and where necessary. I will be giving you basic math formulas and basic rules of vectors. But you should develop these two skills from your side. Then together we can make physics easy. That's the thing. Okay. Right. Now let us come to the point. So EAMCET or EAP set, whatever name you call it. Our question paper pattern is same in both the states. From physics you will get 40 questions and 40 marks. Right. And these 40 questions will be on your syllabus of both first year and second year. Both first year and second year. Okay. Now, what is the syllabus that you have for first year and second year? If you remember, we have got 14 chapters in first year. This is the first year syllabus. Just a minute. I will paste the second year syllabus. So in first year, you have 14 chapters. Second year, 16 chapters. 1, 2, 3, 4, 5, 6, 7, 8. 16 chapters in second year. And that means total you have got 30 chapters. 14 plus 16, 30 chapters. 30 chapters of physics for EAMCET. And from this 30 chapters, you'll get 40 questions. That means from some chapters, you will get more than, definitely you will get one question from each chapter, no doubt about that. But from some chapters, which we don't know which chapters those will be, you will get more than one questions. Okay. And many students have this problem. They will be worried a lot about the weightage of question, like how you have weightage in your IP. In IP, if you take your first year syllabus, you get your long answer questions from which chapters? This work energy power long answer, oscillations long answer, thermodynamics long answer. In second year, you get waves long answers, current electricity long answers, nuclei long answers. Then short answer questions, very short answer questions. You have this standard weightage for IP examinations. Okay. And in the same way, many students worry about weightage of EAMCET. Chapter wise weightage of EAMCET. To be frank, if someone tells you that you'll get this many questions from this chapter, one question from laws of motion, two questions from system of particles, it is not 100% correct. They might be partly true. Strictly speaking, you cannot predict the weightage of chapter-wise weightage for EAMCET. Why? Because it is an online examination. What happens if it is online examination? Suppose if you go back 5-6 years when EAMCET was conducted on as a paper pen based test, then we could predict certain weightage, chapter wise weightage, because throughout the state examination will be held at a single time and everyone will be getting the same question paper when it was held in paper pen based mode 5-6 years back. Okay, but once when EAMCET is changed into online mode, this EAMCET examination will be held for 4-5 days, right? And each day there will be two shifts. Let us say it is held for 4 days. EAMCET is conducted for 4 days. 4 days means each day will have two shifts, morning shift and afternoon shift. That means you will get 8 different question papers. 8 different question papers. And these 8 different question papers will have different weightages, chapter wise different weightages. Let us say a student who is appearing for shift 1, he or she gets Newton's laws of motion, one question. Work energy power, two questions. And another student who is appearing in shift number 2 might get two questions from Newton's laws of motion and one question from work energy power. This can happen. So don't worry about the chapter wise weightage. First of all, take it away from your minds. Don't worry from which chapter how many questions do you get. You forget that. You can't predict that. So it is wastage of time. Forget that. You have to study, you have to prepare for all 30 chapters. Then you can attempt all 40 questions. That's all. Simple. Prepare for 30 chapters. Attempt 40 questions. Simple rule. Attempt 40 questions. And some students, we have different kinds of students. I'm telling you all the different possibilities, how different students think. Some students say, sir, I cannot study 30 chapters. It is not possible for me. Time is less, or I did not concentrate in first year. I'm starting my EAMCET preparation now in second year, and already second year is half completed. So time is very less. I cannot study 30 chapters. I will study only 15 chapters. I'll study only 15 chapters. Then I can expect to attempt some 15 to 18 questions. right? This can happen. Some students can think in this way. I don't suggest that. I don't encourage that tactic, because suppose you have studied 15 chapters. Okay, depending on your convenience. Some chapters from first year, some chapters from second year. You can study it however you want. Now, if you look at the questions, standard of questions that are asked in EAMCET, out of the 40 questions that you get, we can categorize the questions into easy, moderate, and difficult. Okay. How many questions will be easy? How many will be difficult? How many will be moderate? Out of 40, definitely 6 to 8 questions will be easy. Okay. And 6 to 8 questions will be difficult, or make it 10. Around 10 questions will be difficult. So 10 here, 8 here, 18. 40 minus 18 is 22. 22 questions will be moderate. This happens every year for every shift. Whatever all the 8 shifts that I told, if you take any shift, you will find the distribution of questions like this: 6 to 8 easy questions, 8 to 10 difficult questions, and 20 to 22 moderate level questions. Right. Now, this student who has prepared for 15 chapters only, student X who has prepared for 15 chapters, he has left the other 15 chapters completely. That means any question which comes from those 15 chapters, he cannot attempt it. Forget about that. Now, out of these 15 chapters, let us say, due to bad luck or fate, whatever you say, out of the 15 chapters, from 5 chapters for which he or she has prepared, let us say he gets difficult questions. Difficult questions. Then naturally, these 5 questions are also gone. Then he or she will be effectively attempting only 10 questions with confidence. The other ones you have to play lottery. Okay. So this can happen. That's why I don't suggest, I don't advise you to select a few chapters, prepare perfectly for those few chapters. I don't suggest that. It is an extreme last option that you have, but I don't suggest that. Right? Okay. So what is our target now? 30 chapters in physics, 40 questions to be attempted. Out of 40, you should attempt at least 30 questions with confidence. The other 10 questions you can take chance. Okay, but at least 30 questions you must attempt with confidence. And if you get 30 marks in physics, 30 questions means 30 marks. 30 marks in physics, and same proportionately. Let us say you have 80 questions in mathematics. So if you take 60 marks in mathematics and 30 marks in chemistry, what is your total? 120. And if you get 120 marks in total in EAMCET, your rank will be definitely less than 3000. Less than 3000. And if your rank is less than 3000, you can get a seat in your college of choice or your branch of choice. Okay. So please, I will give this as target to all of you. All the students who are in this batch, your target for EAMCET is 120 mark. When for physics, it is 30 mark. 30 mark is a very good score in physics in EAMCET. Okay. Right. Now again, come back to the syllabus. Any questions? Does anyone want to ask something or want to say something? You can raise hand or you can unmute and ask. Anything you want to ask, anything you want to say? Any questions?
Friends, if you have any questions, please feel free to ask, because you have to make all the things clear in the beginning. Once we start the subject, so we should not get any confusion or mismatching. So please raise your question if you have any.
Okay, fine. See, why I'm telling all these things without directly starting the topic is planning is very important. Planning is very, very important. Without proper planning, if you just go on putting your efforts blindly, going on doing hard work, it will not be so much fruitful. If you plan perfectly and execute that plan, smart work is more important. Then you can achieve maximum best result, right? Okay, now coming back to syllabus of first year and second year, we can classify the total syllabus of first year into two concepts. The last three chapters, they come under heat, thermal properties, thermodynamics, and kinetic theory, and all the other chapters, right from chapter number 1 to 11, it is mechanics. Mechanics. So more than 70% of your first year physics is mechanics. Very important part. And of course, this chapter, this one chapter, oscillations, it is related to waves and oscillations, which is continued in your second year, first chapter, waves. Waves and oscillations together is one branch of physics. Mechanics is the other branch. And you come to second year physics, optics, two chapters are there on optics, properties of light. Then charges and fields, potential and capacitance, current, electricity, moving charges and magnetism, magnetism and matter, electromagnetic induction, alternating current. All these chapters, we call them as electromagnetism. Electromagnetism. And these chapters, electromagnetic waves, dual nature, atoms, nuclei, semiconductors, communication systems. These we call them as modern physics. Modern physics. That means in second year you have three concepts: optics, electromagnetism, and modern physics. Electromagnetism has the highest percentage. It's almost 50% of your total second year syllabus. 8 chapters are there in electromagnetism. Then 7 chapters in modern physics. 2 chapters in optics. Okay, right. Now we will start first year topics first, then we will come to second year topics. Let us begin with motion in straight line. Motion in straight line and motion in plane. These two chapters, they are called kinematics. Kinematics. We will start here. Right. So first, motion in a straight line. What is this chapter about? This chapter is all about motion. What is motion? Where, how do you say? See, motion is a very essential thing. We find motion all around us. Suppose if you are sitting idle, inside your body a lot of motion is taking place. Your blood is getting circulated, your air that you breathe is running in your body, right? And vehicles are running on the road, trees, leaves are moving, birds, animals are moving, automobiles are moving, aeroplanes are flying. Our planet Earth is moving around the sun is moving around the galaxy, all the galaxies are moving away from each other. So motion is there everywhere in the universe. That's why we start our study of physics with motion. Motion is very essential thing to understand. And when do you say, or how do you describe that a body is in motion? To understand motion, you should understand what is rest. When do you say a body is at rest? If the position of the body if the position of the body does not change with time, then it is said to be at rest. Position does not change with time, then we say body is at rest. Then obviously, if position of a body changes with time, if position of the body changes with time, then the body is said to be in motion. Okay, basic things. And one more thing is, rest and motion are relative terms. Rest and motion are relative terms. Relative terms. Relative terms means, what does this mean? Take a simple example. Suppose this is a car which is going on a straight road. Two people, A and B, are sitting in the car. And a third person, C, is standing on the road. C is stationary. A and B are moving in a car, let us say in this direction. Okay. If C looks at A, C says that A is moving. If C looks at B, C says that B is moving. So A is in motion for C, B is also in motion for C. But if A looks at B, if A looks at B, what does he say? B is in moving or stationary? Stationary, because both are traveling in the same car. So B will always appear to be stationary to A. But the same B is in motion for C. Then what is the actual state of B, rest or motion? It depends on the frame of reference. It depends on the frame of reference. B is in motion for C and B is at rest for A, because the frame of reference with respect to which C is observing the motion is different, which is this one, XYZ coordinates. And the frame of reference from which A is observing B is different, which is this, XYZ coordinates. So in the frame of reference of A, B is stationary because his either X value or Y value or Z value are not changing. But in the frame of reference of C, the X coordinate of B continuously changes. So C says that B is in motion. That's what we say as relative. Motion is relative. One body which is at rest for someone might be in motion for some other one. Right? For example, you are sitting there in front of your table or whatever, and if you look at the table in front of you, the table is at rest for you, right? And you are also at rest. You feel that you are also at rest. But imagine someone who is watching you from the moon, say with a telescope. Then for that fellow, both the table and you are in motion, right? And the fellow who is standing on the moon, is he at rest? No, moon is also moving around the earth. So that fellow is also not at rest. Like that, if you take someone standing on the sun, is that fellow stationary? Is he at rest? No. Sun is also not at rest. Sun also rotates about its own axis like Earth, and along with rotation, Sun is moving around our galaxy, Milky Way galaxy. So Sun is also not stationary, right? Then if you take our total galaxy as a whole, Milky Way galaxy, this galaxy is also not stationary. You might have studied something called Big Bang theory. The universe was created in a big explosion. So because for that explosion, all the galaxies, they are continuously moving away from each other. That means there is no body in the entire universe which is at absolute rest. There is no body in the universe which is at absolute rest. Absolute rest means rest with respect to any body. You call it as absolute rest. So you don't find any body in the universe which is in a state of absolute rest. Everything is in motion. Okay. Rest and motion. Then, to study the state of motion of a body, we must know certain basic terms like distance, displacement, speed, velocity, then types of speed and velocity, average speed, instantaneous speed, average velocity, instantaneous velocity, then acceleration, then kinematic equations, then graphs to study motion. All these things will go one by one. So first of all, if I take distance and displacement, distance and displacement. Huh. What is the basic difference between these two? How do we define distance? It is the actual path length traveled by a body. Actual path length traveled by a body. Then what is displacement? It is the shortest path. Shortest path between initial and final positions. Right? For example, this is point A and this is point B. A body goes from point A to point B along this path. This is path 1. Then what is the distance? You take a measuring tape or a scale and measure this total path length. You get some 10 meter, 20 meter, 2 kilometers, some value. That is distance. Then what is displacement? Shortest path between initial final positions. Initial position is A, final position is B. And shortest path between any 2 points will always be a straight line. So this straight line, path 1, is also the displacement. Both are same. Distance and displacement are same for path 1. But if the body goes from A to B along this path, like a semicircle, this is path 2, then distance is this actual path length. This actual path length. Displacement is this thing, straight line. Shortest path between A and B, straight line. Okay. That means in this case, distance is greater than displacement. For path 2, distance is greater than displacement. Suppose from A to B, the body goes like in this path, zigzag, random path. Distances, you should measure all this path, you will get distance. Displacement, again, same thing, shortest path between A and B, which is a straight line. So here distance is further larger than displacement. Okay. And remember, distance is a scalar quantity, displacement is a vector quantity. And it is measured in meter. Displacement is also measured in meter. Okay. And displacement can also, it is denoted by, normally in most of the books, we use D to represent distance and S to represent displacement. And displacement can be calculated as final position minus initial position. Formula to calculate displacement, final position minus initial position. Okay. Then, suppose if I give you an example, a person travels 3 meters towards east, then 4 meters towards north. What is his distance and displacement? Easy question. Distance is actual path length, which is 3 plus 4, 5 meters, sorry, 7 meters. Okay. Then what is his displacement? Displacement is the shortest path between initial and final positions. Initial position is this, final position is this. So shortest path will be a straight line. Remember, displacement will always be a straight line. How much is this displacement? If you apply Pythagoras theorem, you get root of 3 square plus 4 square. Root 25, 5 meter. So distance is 7 meter, displacement is 5 meter. Okay. Let us say a person is running along a circular track of radius r. This is radius r. A person is running along this circular track. Okay. For one complete round, what is his distance? He starts from here, goes around, and again comes back to the same point. What is the distance he covered, which is equal to circumference of the circle, right? 2 pi r. But what is his displacement for one round? His initial point was this, final point is also this. And the shortest path between these 2 points is 0. So his displacement is 0. Okay. For half round, that means he starts from here, goes and stops here. Let us say this is A, this is B. Starts from A, stops at B. Then what is the distance covered? It is half of the circumference, 2 pi r by 2, which is pi r. Then what is the displacement? Displacement is the shortest path from A to B, right? And shortest path is always a straight line. So if this is radius, this is also radius. So it is 2r. Displacement is 2r. If he completes 1/4 round, what is distance displacement? If he completes 2 rounds, what is distance displacement? things like this can be asked. Okay. Right. So we will do many other examples also. We'll continue this topic in our next classes. And again, if you have got any doubts, you can ask. Otherwise, we will stop.